Okay, let's take a look at generalizing types of slopes in particular cases of what type of line you have. So the first kind of line that we'll generalize is a line going uphill. Now, when I say uphill, I'm meaning from left to right. And so that idea from left to right actually applies to all of these generalizations. Okay, so if we were to draw a picture of a line going uphill from left to right, it might look something like this. And then to calculate the slope, we could pick any 2 points on the line, maybe this point, oops, this point and this point, and we could see that we would rise and run as such. And if I moved in that direction, my rise would be positive and my run would also be positive. So in that case, my slope would be my positive rise, right? My positive rise divided by my positive run, and a positive divided by a positive would equal a positive slope. Okay, and I'll write that in a moment. But you could also consider two different points because the points you choose don't matter, and you don't have to travel, sorry about that, you don't have to travel in the direction we did here. I could travel down first and then left. And in that case, I would have a negative rise and a negative run. So I would have a negative rise divided by a negative run, but in either case, the slope of this line is positive because a positive divided by a positive is positive and a negative divided by a negative is positive. So a line that goes uphill from left to right has a positive slope. Okay, I've went ahead and put that in a box and I've made three others for the three other cases. You can probably guess that the next case will be a line going downhill. So maybe it looks like this. And I'm not going to do a blue and a red rise and run for all of these now. My point was you could do it in either way and you would get the same final slope answer anyway. Okay, so if I look at this line and I pick this point and I rise negative and run positive, then my slope will be a negative divided by a positive, which of course tells us that we get a negative slope because a negative divided by a positive is negative. Now let's consider the two more unusual cases. Not really unusual, just different. A horizontal line. You pick 2 points on the line, travel from one to the other, so maybe I'll start at the one on the left and I'll travel to the right. Then that's going to give me a positive run because that's a horizontal change. So I know my run is positive, so my slope, I'll say m equals rise, which I haven't talked about yet, divided by the run. Well, the rise from the left point to the right point, there is no vertical change because I don't travel up or down at all to get from the left point to the right point. So my rise is 0. And you can imagine that that's true for every horizontal line. So if you take 0 divided by any positive number, you get a final slope of 0. So the horizontal line always has a slope of 0 because the rise is always 0 and the run is just some number, which could be negative, by the way. If you started at the right point and traveled left, you'd have a negative run. But 0 divided by a negative is still 0. So once again, that illustrates the point. It does not matter which point you choose or which point you start with, your slope will be the same. Okay, last we have a vertical line. So if I pick 2 points on the vertical line and I travel maybe from the top point to the bottom point, that's going to give me a negative rise because that's vertical. So my slope will be negative rise divided by my run. Well, just like on the horizontal line, there is no horizontal change from these 2 points that are stacked vertically. So my run is 0. So we say the slope of this the slope of this line is undefined. You can't divide by 0. So this slope, or this line, you can't even calculate the slope. And some people might say that this slope is infinity, which is also not a number and not terribly useful, but I kind of like it because it's more descriptive than undefined. The reason for that is because whenever your line is close to vertical, so this line is vertical, but if I shift it slightly like that, then what happens is, as you look at your rise and run, your run is really tiny. And when you divide by a really tiny number, you get a really massive number, like infinity. So just want to point that out. Some books or some people might consider the slope of that line to be infinity, but perhaps it's more common in basic algebra books to consider it to be undefined. And that's every case for a line and how to generalize their slopes.